Hello, recording is going on. Bolo.
Yes, sir, it's
Yes, sir.
going on.
Okay. Now, last class what we studied, can you just recall? Just एक बार बोलिए. Last class what I taught you? Past में थोड़ा recall करो ना. Up to what we finished last class. That's almost 1 week is over ना. EMI.
Sir, we finished board question, Lenz's law,
हाँ.
Faraday's law.
Very good.
बस
And
उतना
then
ही किया है और
इतना ही
define
किया.
EMI.
अच्छा, थोड़ा फार्मर्स भी दिया था ना मैंने. लास्ट में बोर्ड क्वेश्चन किए थे ना.
जी
Okay. Okay. So just
फॉर्मूला की क्वेश्चन किया है
okay,
सर.
I'd like to do the recalling so that you will understand better. See, EMI. In this EMI chapter, first what we studied means what is magnetic flux we studied. What is called magnetic flux. So magnetic flux means what? Just first chapter we finished. Electric flux, like that here we are going to study magnetic flux. Magnetic flux का symbol बोलते हैं बेटा. This is magnetism. B means magnetism. This is flux. So magnetic flux. Magnetic flux is equals to BA cos theta. So this I taught you, and depends upon area vector, this cos theta changes. That you know, positive flux, negative flux, 90 degree, 30 degree, 40 degree, कुछ भी दे दो. This cos theta always याद रख लो बच्चों. Each and every step please remember very carefully. If I write cos theta as a third factor, see phi b is having three factors. One is B. First factor is B. B is called magnetic field. Second one is called area. The third factor is called cos theta. So first, if you understand the basic formula, then you will be able to do any kind of numerical. So ये formula ठीक से समझना हमें. B means what? Magnetic field. A means what? Area vector. If you take here area like this, if I draw a normal to this is called area vector. If I take the area like this, then if I draw this is called area vector and this is called magnetic field. So here magnetic field and area vector is the same direction. So theta equal to 0 degree you can say. Here whatever the angle it makes, theta equal to 30 degree, 45 degree, what that you have to say. So magnetic field and area vector. The area vector is always normal. All these things you have the basic knowledge already, just I am recalling. B is magnetic field, A is called area vector. So area vector, this is area vector, n cap, area vector and magnetic field. This is magnetic field line. So ये दोनों का बीच का angle cos theta. That is the third point. So first point after understanding this, B, A, cos theta, three factors. After understanding these three factors, again what you have to understand very carefully, very clearly what you should understand means, what is magnetic flux? What is magnetic flux? Be a casta, you will say, when this magnetic flux will produce, when this magnetic flux will produce, when it will produce means, अच्छी तरह से दिमाग में बिठा लीजिए बच्चों, out of these three, any one should change, any one. Either B, magnetic field change होना चाहिए, तो flux produce होएगा. Magnetic field is not producing. Suppose area is changing. अरे भाई पहले में इतना बड़ा एरिया था, अभी एरिया छोटा हो गया और छोटा हो गया, तो एरिया चेंज हो रहा है. ओके, फ्लक्स विल प्रोड्यूस. द थर्ड फैक्टर इज cos थीटा. मैग्नेटिक फील्ड भी कांस्टेंट है, एरिया वेक्टर भी कांस्टेंट है, बट cos थीटा एंगल इज चेंजिंग इन बिटवीन दिस टू, देन आल्सो फ्लक्स विल प्रोड्यूस. ये भी पॉइंट आप याद रखना. तो गौर से सुनिए, either if you want to produce the magnetic flux, when the magnetic flux will produce, either you should change any one factor should change. B should change, or A should change, or cos theta should change. तो ये एक एग्जांपल भी हमें देखेंगे. If magnetic field is changed, how the flux is produced. That's what the Faraday's law. That's what the complete Faraday's law. Faraday law क्या बोला भाई? Simply you have taken a coil and this coil is connected with a galvanometer. Coil के साथ galvanometer आपने connect कर दिया. Now you see that magnetic field lines. B is the symbol called magnetic field lines. When this magnetic field lines change, how the flux is produced. So when you bring the north pole of the magnet, south pole of the magnet forcibly towards the coil, यहाँ पे जितना भी magnetic field lines होता है, so it goes and hits the coil. So it changes. Magnetic field lines changes. It hits. So when the magnetic field line changes, then flux is produced. The second factor, third factor, hereafter only we are going to see in this chapter. how the area is changing, how the flux is produced, how the cos theta is changing, how the flux is produced. Hereafter only we are going to see these two questions. So first question we finished. So this is the recalling activity. First part we did. Now, second part, what I would like to share with you. Okay, hello, 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 hello. You are getting my voice? Jai Boli Avacham.
Yes, sir.
Girls, are you getting my voice? Please tell me. When I talk from here, are you getting my voice?
Yes, sir.
Yes.
Okay. So first thing I hope that you understand magnetic flux हमें देख चुके हैं बच्चों. So what is magnetic flux? Phi B is equals to dA cos theta. So this is the first point. First point in EMI. Second point is when this flux is produced. बेटा वो भी हमें देखे. When flux is produced. Flux produced. So this also we have seen either any one should change, either B should change, A should change, or cos theta should change. So first factor B, how the B is changing, magnetic field goes and hits the coil. So flux is produced. So Faraday's law, all the magnetic fields के बारे में हमें Faraday's law we studied. Faraday's law. Now hereafter only I'm going to teach you how the area is changing. So इसके वजह से area change होने से how the flux is produced. Then the third question, last 5 mark question, we are going to see when the cos theta between B and A, when it changes, how the flux is produced. All this question hereafter we are going to see. Okay, so this is what I got you. Now second part is what you should understand. देखो बच्चा यहाँ पे थोड़ा फार्मर्स मैंने दे रहा हूँ वो फार्मर्स भी नोट कर लीजिए. EMF, they ask you EMF produced. EMF produced. Note down the formula. Formula बल्कि लिख लीजिए. Today, what are the formulas are written? SI unit and no need to recall because already I did. SI unit you know. EMF. EMF is EMF का formula है d phi by dt. Delta phi by delta t बोल सकते हैं. Suppose if they ask you E average, EMF का average find out करो. जब बोला तो आपने क्या करना है बच्चों? डेल्टा फाइव बाई डेल्टा टी का मॉडुलस ले लो. डेल्टा फाइव का डेल्टा टी का मॉडुलस वैल्यू ले लो. और इफ दे आस्क यू E instantaneous d phi by dt, this formula also you can use. You know that if any equation is given, we are using this formula. आपको पता है 11th standard में we did that differentiation form में एक equation दे दिया, find the EMF produced. So you have to use this kind of formula. Okay, so note down these things. And if resistance is first, second formula. If resistance is given, if resistance is given to find I, current push रहा resistance देखो, so I average, EMF average, this is nothing but Ohm's law. है बेटा, V equal to I, देखो इसका देखो क्रॉस मल्टीप्लाई करके देखो, V equal to IR Ohm's law, यहाँ पे देखो E equal to IR, so this is nothing but Ohm's law. So I average equal to E average by R, you have to find out. Now, after noting the formula, I'll give you a small numerical, very small numerical, 1 mark numerical. Let us understand the numerical. Shall I rub the board?
No, sir. No. 1 minute.
Yeah. Voice over. Voice. Hello. हो गया? Okay. Now
Yeah.
I'll
Yeah.
do one small numerical. One small numerical. We will try to do that. Okay, by using this formula. देखो बच्चों एक न्यूमेरिकल पूछा है, if the magnetic flux is if the magnetic flux is given by if the magnetic flux is given by 5t square plus 4t plus 1 find induced EMF induced EMF at time equal to 1 second. So can you do it yourself by using the formula? अभी जो फार्मूला दिया था उसका यूज करके बोलिए.
सर
Please
रेड
louder.
पेन पे नहीं दिख रहा है
क्या बेटा?
क्वेश्चन.
क्या बेटा? Louder please.
सर रेड पेन से बोर्ड नहीं दिख रहा है सर.
Okay, okay. Sorry, I'll change. Sorry.
प्रॉब्लम.
5t square plus 4t plus 1. Find induced EMF at time equal to 1. T equal to 1 second. If the magnetic flux is, I'm reading, if the magnetic flux is given by 5t square plus 4t plus 1, एक इक्वेशन दे दिया मैग्नेटिक फ्लक्स के बारे में. इंड्यूस्ड ईएमएफ पूछ रहा है 1 सेकंड पे. हाउ टू डू? इक्वेशन दिया तो क्या करना है बच्चों? यू नो दैट इक्वेशन इज द इक्वेशन. या इंड्यूस्ड ईएमएफ का फॉर्मूला क्या होता है? d phi by dt. d phi by dt. So first what you have to do? So first you should find out phi is given as phi. Flux is given. हम दिया ना flux is given by. तो लिख लीजिए flux is given as pi t square plus 4t plus 1. तो इसका with respect to time differentiate करके बताओ बेटा. Who will say? 11th standard question. So what is the answer for this? What is d phi by dt? What is the answer?
Plus 4, sir, 10 e plus 4.
Very good. Very good. So 5 को बाहर निकाल लीजिए. तो differentiation of t square nx power n minus 1. So 2 into t. Nx power difference. What is the formula? D by dx of x to the power n. याद आया? D by dx of x to the power n. याद आया? Nx to the power n minus 1. So this is the differentiation formula. In 11th standard we studied nx to the power n minus 1. 11th standard में आप पढ़े हैं. तो देखो, so c square है तो कितना है बेटा? 2t2 minus 1. Okay, plus.
सर.
हाँ.
सर so sorry, can you repeat the question?
If the magnetic flux, if the magnetic flux is given by एक equation दे दिया. Okay.
जी जी.
One equation is given 5t square plus 4t plus 1. Find the induced EMF. Induced EMF पूछ रहा है. Okay.
Okay.
So 5 into 2t plus 4 dt. t को differentiate कर दो 1. So that this is the answer. Therefore d phi by dt differentiation answer क्या मिला आपको? d phi by dt equal to 10t plus 4. Now at t equal to 1 second, the question it is given at t equal to 1 second. So write down at t equal to 1 second. d phi by dt, how much you will get? d phi by dt will be equal to 10 into 1, 10 plus 4, 14 volt. So is the EMF equal to 14 volt is the answer. Please copy. After finishing, please tell me, we'll go to the second question, second numeric. Diagram based question, 1 mark question. Yeah. Okay. You yourself, please tell me yes, okay, so that I will understand it is online class, बच्चों. I cannot wait for so long time. After finishing, you tell me yes or yeah. Ali is there? Ali? Aisha?
Yes.
Faliha?
Yes, sir.
Nishta? Nishta is not there?
Yeah, I'm there, sir. I'm done.
Shall I rub the board? Hello?
Yes, sir.
Hello, bachon, boliye, shall I rub the board? Now, very less participants. Muhammad Ali, Ayaz is there, Derwin is there, or Faliha, Fatima, Man Patel. Oh, Fatima. Hello, Fatima, are you there?
Yes, sir.
Hello. Good. You are from Saudi or India?
India, sir.
Okay. Nishta, Rayyan is there, Rihab is there, Samir is there. Good. Samir बेटा कहाँ से अटेंड कर रहा है? सऊदी से यहाँ से?
सर कश्मीर से
कश्मीर माशाल्लाह माशाल्लाह एप्पल ला भाई एप्पल लाओ सुरैया जोहा ओके गुड ओके बेटा नाउ next question we'll see so like this kind of question 2 mark में पूछ सकते हैं very simple question only not difficult question very simple question they may ask in 2 mark question क्योंकि 11th का concept याद रखना चाहिए खलास differentiation ये concept याद रखते हैं nothing else now the board questions you will see one more board questions last class I taught you that question again I am repeating a diagram based question diagram based CBSE question diagram based so last class I gave you one question from that continuation is there let us recall that question okay so the first thing is two things you should understand current flow induced current flow means suppose if I take a battery and then if I give you a circuit connection you know that from positive to negative charge if the current is flowing इसको बोलते हैं हमें conventional current from positive to negative if the current is flowing we call this as a conventional current first one we call it as a conventional current a first part second part you know that if the current is flowing from negative to positive what we call can anyone tell me what we call negative to positive what does it the name is called negative to positive can you say
Electronic.
very good electronic current ये सब थोड़ा बेसिक नॉलेज होना चाहिए बच्चों ओके कन्वेंशनल करंट इलेक्ट्रॉनिक करंट देन थर्ड पार्ट वी कॉल दैट टुडे नाउ ईएमआई में हम एक पढ़ रहे हैं induced current this is not the normal current induced current what is the meaning of induced current which opposes the cause इसको याद रखना opposes the cause बोलते हैं opposes the cause ये सब ये याद रखें तो induced current if you remember only you can do this diagram based question now who are all the responsible to conduct the current that also you'll see basic knowledge so protons basically we say that protons are positively charged particles this is responsible to conduct the positive charged particle protons or you can say electrons negatively charged particle if protons are more then positivity is conducting if electrons are more electrons are conducting mostly electrons are conducting used to say suppose if you take an electrolyte ले रहे हैं तो यहाँ पे हमें बोल रहे हैं this electrolyte is connected to a circuit like this electrolyte में हमें क्या बोल रहे हैं बच्चों we call this both ions positive ions and negative ions they are responsible to conduct both positive ions and negative ions they are responsible to conduct the electricity so all this basic knowledge थोड़ा रख लीजिए तो normal current is different induced current क्या होता है उसको oppose करने वाला opposite side का बोलते हैं induced current okay so now till now you remember this now you will see the question you will understand so first question last class I gave you again that question I'm repeating suppose if I put the cross question number 1 if I put the cross so what's the meaning बच्चों जल्दी बोलिए if I put the cross
Going magnetic field going inside
magnetic
keyboard.
fields are going inside very good now the question they asked the first question already we did this in your notebook it is there just recalling only so I kept a coil here I kept a coil here like this I kept a coil here now I'm asking you in which direction induced current, see my word, induced current will flow if the magnetic field is increasing. The question they will give in the question paper is, after giving the diagram, they will give a sentence. If magnetic field is increasing, if magnetic field is increasing, in which direction? In which direction? Induced current flow. Induced current flow. So this is the question, 1 mark question, board question. तो आप क्या करेंगे बच्चों? तो आपने मैंने बोला, so first we have to find out the normal current flow का direction आपको मालूम होना चाहिए. What? How to find out the normal? You will use the right hand thumb rule. So if you take this is the current direction, this is the magnetic field line. If you take this is the current direction, this is the magnetic field line, vice versa. You know that. Now you see that if you take the cross as a magnetic field line, so this is the magnetic field line they will give here. B vector is going inside the board. The magnetic field lines are going inside the board. So I'm keeping the thumb like this. Magnetic field lines are going inside the board. Now see my folding fingers are in this direction. So it goes like this direction. Therefore, normal current will flow in anti-clockwise direction. सही है? This is called anti-clockwise direction. Yeah, clockwise direction. What is this direction? Clockwise direction or anti-clockwise direction? This direction. जल्दी बोलिए. This is the clockwise direction or anti-clockwise direction?
Clockwise.
Clockwise.
Clockwise direction. If normal current flows in clockwise direction, what is the induced current will flow?
Anti-clockwise.
Anti-clockwise direction. Very good children. Very good children. So you will write the answer as solution. Answer as anti-clockwise direction. So this is the answer. Those who didn't attend the first class, please note down. Okay. Now we go to the second question. Second question, you have to do the answer. You have to tell me the answer. Second question. Suppose if the magnetic field is given like this, magnetic field lines are given like this, dots. Note down the question in your notebook, please. The magnetic field lines are given like this. Now, a rectangular loop is placed like this. This is the magnetic field lines are increasing. Magnetic field lines are increasing. B vector dots are B vector. Magnetic field lines are increasing. Rectangular loop is placed like this. Name of the rectangular loop is I am giving A, B, C, D. In which direction? In which direction induce the current flow? बोलिए.
Then clockwise. It
बोलिए
will
बेटा.
go clockwise. Clockwise, sir.
Clockwise. Who said?
I answer.
Ayan. कौन बोला भाई? अयास बोला.
Yes, sir.
Very good, अयास. तो देखो अभी देखो चेक करेंगे. So now dot is there. The magnetic field lines are increasing. Dot is there. Dot means it is coming out of the board. Dot. First you see that dot is given. Magnetic field lines are coming out of the board in the increasing direction. The increase or magnetic field lines are increasing. Now the normal current will flow. This is the magnetic field line means the folding finger gives the current direction. So this is the anti-clockwise direction is the current direction, normal current direction. तो उसको oppose करने के लिए induced current will flow in the clockwise direction. So solution is very good child, very good. Clockwise direction is the answer. Very good. Clockwise direction. So if you write like this is the 1 mark question. This type of question usually I'll ask in half-yearly exam if chances are given. Okay. So third question we do. So this type of question, if you see that inside the magnetic field only the coil is kept. देखो बेटा ये दोनों में मैंने क्या दिया हूँ? Inside the magnetic field. That is magnetic field here going inside. I kept the coil also inside the magnetic field. और यहाँ पे देखो बेटा magnetic field lines are going outside. I kept the circular rectangular coil inside the field. Now we are going to see different type of question. Share up the board.
Yes, sir.
Okay. Third question. You think and give me the answer. Okay. Third question. Third question. Suppose if the current is going, third question, if the current is going in a conductor like this. So this is the AB is the conductor A to B. Okay. connected and increasing current is there. So current is going in this direction. Now, if I place a rectangular coil like this, here I am placing. Note down the rectangular coil direction. So, the induced current so the induced current direction in the coil. First you think and give me the answer. Yes, who can give me the answer? Here you write down, here also current, here also you write down, this is current increasing. Current increasing. Current increasing direction. So here to be current increasing direction is given. What is the answer?
Sir, current will go downwards.
Downwards. Now the question is, show the induced current direction in the coil. Show the induced current direction in the coil. What is the answer? What is your answer? Anyone? Darwin? Darwin
Sir,
Purida?
clockwise.
Darwin
Sir,
Purida?
clockwise.
Clockwise direction. How? How many
Right
are?
hand thumb.
Huh?
Right hand thumb. Right
अरे
hand thumb.
अरे बच्चों थोड़ा explain करो ना भाई. How you said clockwise direction? Please, can you explain me how? You should explain now. Okay. Let me explain you. देखो बेटा very clearly. First thing is you should understand. The first thing is you should understand in which direction magnetic field is there in the coil. In which direction magnetic field कौन सा direction में आ रहा है पता नहीं है हमको. Current तो यहाँ पे जा रहा है. Current is going in this conductor. A coil is kept here. No relationship between the magnetic field and the current. तो उसका relationship बनाइए. First you should bring the relationship between current and the magnetic field line. Then only you have to find out. And magnetic field line एक coil पे कहाँ पे जा रहा है पता नहीं ना. Magnetic field कैसा है कुछ भी पता नहीं है. I don't know anything. Then how I will say clockwise, anti-clockwise? Only two option is there. Either हिंकी पिकी पान की डाल के clockwise, anti-clockwise कुछ भी लिख दो class. नहीं ऐसा नहीं हो सकता है ना बच्चों. So first thing is you have to use the right hand thumb rule again here. देखो बेटा यहाँ पे गौर से सुनिए कैसा कर सकते हैं this kind of numerical. How beautifully we can do. I'm using the right hand thumb rule. See this thumb rule is I'm keeping right hand thumb rule current यहाँ पे लिखा है current increasing direction. So current direction पे मैंने thumb रख रहा हूँ. यहाँ पे current direction में रख दिया. Now carefully watch that my folding fingers. It comes in which direction? Folding fingers. Outside the board?
Yes, sir.
Yes or no? Outside the board. Folding fingers.
Yes, sir.
Hello. Tell me now. When current is going like this, my folding fingers comes outside the board or not? Or is it going inside the board? Outside the board na?
Yes, yes, sir.
So outside the board means we will use dot or cross. Outside the board means which symbol we will
Dot.
use?
Dot.
We will use. So put the dot here first. Put the dot here. So putting the dot, now I understand if I put the dot here by using the right hand thumb rule, if I put the dot here inside the coil, now I understand very clearly. Dot means magnetic field lines. So here magnetic field lines comes out of the coil like this, out of the coil like this. So magnetic field direction के लिए मैंने thumb right hand thumb में thumb rule use कर रहा हूँ. देखो right hand का thumb rule. If the magnetic field line is like this, now current direction in the coil which direction? Current direction. Tell me. Normal current direction which direction?
Anti-clockwise.
If the dot represents the magnetic field lines, imagine that if the dot represents the magnetic field line B vector. Now, normal current flow in which direction in the coil? See my hand. Normal current flows in which direction? इसको क्या बोलते हैं? Anti-clockwise direction. तो उसको अपोज करने के लिए what I have to write? Induced current. What is the direction?
Clockwise.
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 So the answer is clockwise. Very good. Answer is clockwise. Good. Answer is clockwise direction. So the concept is, if you don't know, if you forget means step by step you write. First, find magnetic field. First to find magnetic field direction in the coil. This is the first step. First to find magnetic field direction in the coil by using thumb rule. By using thumb rule, find normal current direction. Normal current direction. Third one is opposite to normal current direction is the answer. Alas, only 3 steps we are following. So first thing is you have to find out magnetic field direction. Current is given, so magnetic field direction you are finding. Second step is you are applying thumb rule to find out the normal direction current. Third one is opposite to normal direction. You are saying the answer. Alas. Okay?
नहीं सर.
Sir, could you read the first one?
First to find the magnetic field direction in the coil. First to find the first you have to find the magnetic field direction in the coil. Okay? हो गया बच्चों?
Sir, the last one is opposite to normal current.
Direction is your answer. Opposite to
Direction.
normal current direction is the answer. Opposite to normal current direction is the answer. Navya, is there Navya? Ayman is there?
Yes, sir.
Ayman, तो participant list लेके भेज दे बेटा please. Hello, Ayman, are you there?
Yes, sir.
Can you send me the participant list?
Okay, sir.
Okay. Understand हो गया? Up to this numerically you understand? I hope so. Now, next question. So question number 4. Question number 4, you tell me what is the answer. Okay? Just I am changing one small thing here. Question number 4. I'll rub the answer. Now you tell me. If the current increasing direction is like this, if the current increasing direction is A to B like this, A to B. So show the induced current in the coil.
Anti-clockwise.
Step by step बोलना है. Very good. Anti-clockwise. How you said? In the coil, in which direction magnetic field? Coil में magnetic field and direction कैसे जाएगा? Coil पे magnetic field direction, how it goes? Magnetic field direction.
Outside the.
Oh my God, wrong. देखो, current is increasing in this direction. So current is increasing in this direction. Thumb रख दो. Now you see that my folding finger. Folding finger is what is doing? Going inside
Going
or outside? Going inside or
Yes.
outside? First you tell me
Going
inside or
inside.
outside? Huh?
Going inside. Going
Going inside.
inside.
Going inside, what is the symbol?
Cross.
Cross. Cross. Use cross. So put the magnetic field line. Now see this. I put the cross. So magnetic field lines अंदर जा रहा है. So use the thumb for magnetic field lines अंदर जा रहा है. Now you see normal current direction is this the clockwise direction. So clockwise direction में normal current flow. So इसको oppose करने के लिए anti-clockwise direction is the answer. Answer is anti-clockwise direction. ACW means anti-clockwise direction is the answer. Now one more beautiful concept I am going to give you. हो गया? Fourth question हो गया?
Yes.
हो गया? Not 1 mark question only. Nothing to worry. It's not a 2 mark, 3 mark, 5 mark. No. Just case-based study or 1 mark question. You should know the concept. But all the questions are concept-based questions. Side of the board. Suraya.
जी सर जी.
Okay. Suraya says okay. Now next question, fifth question. Till now, listen very carefully. Listen very carefully. Till now, what is the word I am using? Listen very, very carefully, बच्चों. Current increasing direction. Current is increasing direction. Current is increasing direction. Or magnetic field is increasing direction. कुछ तो कुछ increasing the word I am using. Magnetic field दिया तो magnetic field is increasing direction. Current दिया तो current is increasing in direction. बोल के मैंने word दे रहा हूँ. अभी देखो I am going to change the word. Now you tell me the answer. This also you should remember. All are concept based questions. So question number 5, note down question number 5. Oil is here. A to B. Current decreasing direction. Decreasing direction. So the induced current direction in the coil. Wonderful children, give me the answer. Clockwise or anti-clockwise? Very good.
So it is anti-clockwise.
Anti-clockwise. Okay, very good. Any other? Who said? Ali?
Yeah.
Very good. Congratulations. 0 mark. Any other child? Salsabil.
Yes, sir.
बोलना बेटा.
Doing, sir.
आंसर बोलो बेटा. 1 mark क्वेश्चन फटाफट बोलना रे बेटा. अयास चुपचाप बैठा ना रे अयास. Ayman.
Sir, anti-clockwise.
Faliha, Fatima, Man Patel. Saudi or India?
सऊदी में ही हूँ सर 3 दिन में जा रहा हूँ.
Okay. Musfira, from which place? Musfira, Saudi or India?
India.
India, good. Rihab, कहाँ से भाई Rihab? अरे Rihab, from which place? India or Saudi? Okay, not responding. Okay बच्चों, देखो बच्चों, मैंने बोला यहाँ पे word दिया decreasing current decreasing बोला मैंने. So please, all of you note down very, very important concept. Note the concept. Note. If increasing current is given, if increasing current is given, it opposes. So लेंस लॉ का अप्लाई कर रहे हैं. If A option A, option B, if decreasing current is given, it should favor the direction. It should favor What is the meaning of favor? Favor the normal direction. अरे favor को तो क्या है भाई? What is the meaning of favor? Opposing means against. What is the meaning of favor? Favor करना है. उसका ही
Along.
साथ चलना है. हाँ, favor means उसको favor करना है. That means normal current direction को ही favor करना है. Decreasing current is given. That is the concept. याद रखो बच्चों, decreasing current is decreasing direction is given. Now what's the answer? You will see. I'll explain you further. देखो बेटा, so current is decreasing direction. So I'm keeping my thumb direction. Thumb रख रहा हूँ. See my pointing fingers are going inside. So pointing fingers are going inside. Inside means I have to use cross. So if I use cross means magnetic field line. So देखो बेटा, magnetic field lines are going inside. That is I'm keeping my right hand thumb rule. Magnetic field lines are going like this. Now normal current is producing in this direction. So this is called a clockwise direction. तो इसको बोलते clockwise direction. So normal current का direction में ही favor करना है because of decreasing current. Because of decreasing. Okay. So answer is clockwise direction. Clockwise direction is your 1 mark answer, case based study. Please note down very important concept. हो गया? जोहा हो गया?
Yes, sir.
Clear of the board? बच्चों बोलिए. Suraya, clear of the board?
जी सर जी.
Now, next question, please give me the answer. Very beautiful, 1 mark. All are board question, okay? Different questions, but based on our concepts only, based on our previous chapters, based on our previous formulas. That's why I'm telling you, all the chapter formula, please never forget. Recall, most important. Okay, beta? पढ़ते रहना. Now, one more beautiful question. Sixth question. Area current equal to constant बोल के दे रहा है. So constant current flows. 5 ampere means 5 ampere flows. 10 ampere means 10 ampere flows. A to B. Equal to constant. I is not increasing. I is not decreasing. याद रख लो बच्चों. I is neither increasing nor decreasing, but I is constant. So this is the question. Now, a rectangular coil is given in this direction. Rectangular coil is moving from here to here. So this is the given velocity moving. Current तो यहाँ पे जा रहा है भाई. Rectangular coil from here it moves like this. Okay, it's going like this in this direction. So find the induced current in the coil. Think and tell me.
So load test.
Think करके बोलिए.
Yeah, sir.
हो गया? हो गया? फलीहा, आयशा.
Sir, load test किसको होता है?
No? No induced current.
Load.
क्या बेटा?
Yes. Load test square sir. ये constant है.
बेटा थोड़ा आवाज से बात करिए बेटा प्लीज. I'm not getting audio. Please keep your volume high.
Sir, ये current होगा क्योंकि constant है.
हाँ, करंट तो कांस्टेंट है. करंट तो कांस्टेंट है. बोलिए anyone who can give the answer जल्दी बोलिए टाइम हो रहा है clockwise or anti clockwise or no movement the answers are
No
given
movement.
option A clockwise option B anti clockwise option C no direction
Clockwise.
बोलिए बेटा clockwise anti clockwise no direction कौन सा बोलेंगे A B C which option is correct
C.
C is correct okay some children say C any other children wants to change
A.
अरे फलिया फातिमा मुख खोलो ना भाई आयशा
Sir, not A.
हाँ
A. Option A.
ऑप्शन ए वेरी गुड ओके फातिमा आयशा ये आयशा क्या कर रही है भाई खा के सो रही है
फिर मैं वो क्लास में
हाँ बोलो जल्दी बोलो सुरैया जोहा आंसर बोलो
सी
सी ओके some children say C some children says B some children says A now we will see the concept very clearly current is constant current is constant do you know magnetic field versus distance magnetic field versus distance there is a relationship between do you know the formula relationship between magnetic field and the distance r can anyone tell me the formula for this first जल्दी बोलिए इसका कॉन्सेप्ट क्या होता है स्ट्रेट करंट कैरिंग कंडक्टर में हमें देखे हैं स्ट्रेट करंट कैरिंग कंडक्टर में फोर्थ चैप्टर मूविंग चार्जेस if current is
Inversely proportional, sir.
tell me the formula alone what is the magnetic field due to straight current carrying conductor what is the magnetic field due to a straight current carrying conductor infrared current carrying conductor any one child oh my god okay I'll make you some clue दे रहा हूं उसके बाद बोलिए थोड़ा क्लू दे रहा हूं उसके बाद बोलिए एक स्ट्रेट करंट कैरिंग कंडक्टर था इस पॉइंट पे मेरे को मैग्नेटिक फील्ड चाहिए तो यहाँ से मैंने एक एंगल बनाया phi 1 और यहाँ से मैंने एक एंगल बनाया phi 1 now can you tell me what is the magnetic field का formula with the distance d or r what is the magnetic field का formula due to straight conductor b is equals to
Mu naught I by 4 pi r.
very good boy fantastic that's what I want so mu naught I by 4 pi r into sin phi 1 plus sin phi 2 if it is the point is सेटअप है तो क्या करते हैं बेटा sin phi 1 स्पेशल केस में क्या करते हैं sin phi 1 sin phi 2 99 लेते हैं so 1 plus 1 if you substitute means b vector equal to mu naught I by 2 pi r अरे भाई अब mu naught I by 4 pi r रहने या mu naught I by 2 pi r रहने कुछ भी रहने we want the relationship between magnetic field and distance so what's the formula Ali mashallah so b vector is equals to mu naught I by 2 pi r or you can say b vector is equal to mu naught I by 4 pi r दोनों फार्मूला में देखो आप क्लियर से देखो बच्चों magnetic field and distance magnetic field and distance is it directly proportional or inversely proportional जल्दी बोलिए is
Inversely.
it very good child so it is inversely proportional this is what I want from you तो देखो बच्चों क्या बोल रहे हैं magnetic field is inversely proportional to distance so this is what the first concept note magnetic field is inversely proportional to the distance this point you have to this point only we are relating to this numerical so देखो बच्चों all the numericals I told you first thing is you have to find out where is the numerical where is the magnetic field is produced where the numerical magnetic field is produced first we have to find out the magnetic field तो current तो दे दिया ना भाई यहाँ पे current is going constant so how the magnetic field is produced so first we have to talk about the magnetic field यहाँ पे so first we will see this देखो current whether it is increasing current decreasing current constant current ये हाथ तो रख दो ना राइट हैंड टेम्पोरल यूज करना तो करंट का डायरेक्शन मैंने रख दिया अभी देखो my pointing finger goes inside so can I put cross जल्दी बोलिए can I put cross
Yes, sir.
so if I'm using the cross here तो क्रॉस डाल के बी वेक्टर डाल दिया मैंने तो मैग्नेटिक फील्ड तो गौर से सुनिए बच्चों मैग्नेटिक फील्ड इज गोइंग इनसाइड द कॉइल कॉइल का अंदर मैग्नेटिक फील्ड अंदर जा रहा है नाउ magnetic field, the coil is not stationary. Coil, with respect to the conductor, coil is not stationary. Coil is moving away. Velocity of the coil is moving away from the conductor. So when the coil is moving away from the conductor, so distance versus magnetic field के बारे में बात कर रहे हैं, तो distance थोड़ा धीरे 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 बाहर जाने में क्या होता है भाई देखो, if the current is increasing, magnetic distance, sorry, if the distance is increasing, magnetic field is increasing. तो distance increase होने पे, coil move होने पे, तो क्या होता है बेटा, magnetic field decrease हो रहा है. So I am saying second part, this is the first part. Second part I am taking the magnetic field is decreased. Magnetic field is decreased inside the coil, inside the rectangular coil. So magnetic field is decreasing direction में हो गया. Now you tell me, if the magnetic field is in decreasing direction inside, now the normal current flows which direction? बोलिए,
Clockwise.
right hand में ये क्या direction होता है ये?
Clockwise.
Clockwise. So A is the answer. Why? Because the decreasing direction it should favor. Because of the decreasing direction it should favor the direction of the normal flow. Therefore, answer is clockwise. So what a beautiful concept there. Please note down. हो गया बच्चों?
Yes.
हो गया सर.
Very good. Shall we go to the next question, Ayman? Darwin, Ayman, are you there or not? जल्दी बोलिए. Darwin. Hey, Ayman.
Yes, sir.
Are you getting my voice?
Yes, sir.
हाँ. Ayman, share up the board. जल्दी बोलिए. Hello. Simon fellow is not at all opening his mic. Very bad fellow. क्या कर रहा है पता नहीं भाई. फनीहा, आयशा, जोहा, हो गया? Share up the board.
Yes, sir.
Now one more question. One more beautiful concept. Same thing. Please don't forget. Same thing. Whatever I taught you, remember this and you apply for this question. Okay? Same. इसका दिमाग में थोड़ा रख लेना बच्चों. जो भी ये क्वेश्चन देखे थे वो कॉन्सेप्ट पूरा दिमाग में रख लीजिए. Now you tell me the answer for this question. I is constant. What is the number? Question number क्या है? Hello. What is the question number?
7 है सर.
7. Again, current is constant. Current is constant. A rectangular coil moving in this direction. V for direction. Find induced current in the coil. A, clockwise. B, anti-clockwise. C, no current produced. जल्दी बोलिए. Who is a brilliant child? You will see.
Sir, B.
Okay. जल्दी बोलिए. Hello. Ali said C is the option. सर यार आयशा, आयशा,
Yes, sir.
आयशा, बोलो भाई.
So, 1 minute.
सुरैया, जोहा, निष्ठा. Ayaz, happily sleeping, Ayaz.
Sir, anti-clockwise.
Okay. One boy is saying anti-clockwise. One girl is saying no. One more girl. फलिया का आंसर क्या है? फलिया, सुरैया, जोहा, आपका आंसर क्या है? कुछ तो बोलना भाई.
Anti-clockwise.
Anti-clockwise. Okay. Now you see the answer. Again, I told you to go through the previous concept. B vector is equals to mu naught I by 4 pi A. Hey, बच्चों, when the magnetic field is produced, either anyone should change. I constant हो गया भाई. A means what? A means what?
Distance.
Distance. This current का current carrying conductor और इसका distance always is same. Always same. यहाँ पे भी same. यहाँ पे भी same. अरे यहाँ पे आया काइल यहाँ से यहाँ आया भाई. Again the distance is same. So distance is same. A is also same. I is also same. A is also same. So no magnetic field is produced. Option C is the correct answer. No current is changing. No distance is changing. So no current is produced. This is the concept. Now last question we are going to finish. 8th question, one more question. जल्दी कर लीजिए बच्चों please. हो गया बच्चों? Shall I rub the board? Hello, shall I rub the board?
जी सर.
Now one more beautiful question and last question. और आयमन का कुछ एनसीईआरटी का एक डाउट था, उसके लिए हम अभी क्लियर करेंगे. आयमन, do you remember one doubt you sent? Hey Ayman, monkey fellow, Natal. Is the reddish visible to you?
नो सर.
Please give me your valuable answer. देखो बेटा, क्रॉस दिया है. क्रॉस मींस मैग्नेटिक फील्ड लाइन दे दिया आपको. तो मैग्नेटिक फील्ड लाइन यहाँ पे दिया है. क्रॉस मींस मैग्नेटिक फील्ड लाइन इज गिवन. Cross means you know magnetic field line direction, which direction it goes. Inside the board or outside the board?
Inside the board.
Very good, children. So magnetic field lines are going inside the board. Now a circular coil is there. Circular coil I am bringing in this area. Here white board is there. Here only magnetic field line is there. Here white board is there. whiteboard is there. Here magnetic field lines are going. So I'm taking a circular coil. Sorry, correct exact circular coil, spherical coil. I'm taking inside like this. I'm making a movement. Now from the field is not here, but field is here. So outside there is no field. Here field is there. Now I'm making a movement. Now the circle is going from outside to inside entering inside the magnetic field. Now you tell me in which direction current flows, induced current flows. Yes, जल्दी बोलिए. Clockwise or anti-clockwise? Yes, clockwise or anti-clockwise?
Clockwise.
Clockwise. How? Can you explain? Just you give your explanation, if it is possible. थोड़ा explain करो ना. Okay. Now listen. The coil is moving inside. When the coil is moving inside, slowly you see that which area it is covered, that is changing. So when the coil is entering, अभी देखो magnetic field में एक area का area इतना ही हुआ, है ना? Or the coil is moving inside means again quarter will come. Again when the coil is inside increasing means the area is going on changing. The area is going on increasing. Therefore, current is produced. That is correct. That means increasing area. Now magnetic fields is going like this. Magnetic fields are going like this. Now in this coil, तो coil में कैसा current produce होएगा? अगर ये coil अंदर आ गया तो कैसा produce होएगा? What is this direction? ये direction क्या बोलते हैं?
Clockwise.
This direction is called. What is this direction?
Clockwise.
Clockwise direction. So increasing area होता है. So increasing magnetic field होता है. So it is clockwise direction. तो उसका opposite क्या होता है?
Anti-clockwise.
So
Anti-clockwise.
solution answer is anti-clockwise direction. That's all, बच्चों. Now next question. Numerical we will see. Very simple question I'll give you. Okay, very simple question. हो गया? इसका हो गया? Answer हो गया? हो गया? Clear up the board? Okay. Now one more board question, not diagram based question. It is a 3-mark question, or you can say mostly 3-mark question. Now 3-mark numerical we are going to see. Little bit you have to understand the concept here. Okay, 3-mark question. Board question भी ये भी था. A rectangular loop area. Take down a rectangular loop area. A rectangular loop area 20 into 30 centimeters. 20 into 30 centimeters is placed in a magnetic field. Is placed in a magnetic field of 0.3 Tesla. 0.3 Tesla with an inclination of 30 degree. The inclination of 30 degree to the field. Find flux produced. Very beautiful numerical बच्चों. Try to understand the concept. आपको समझ में आ जाएगा. After noting down the numerical, please tell me.
Done, sir.
Okay, one. Hello, only one,
Done, sir.
two,
Done, sir.
three. हेलो हेलो हेलो, जल्दी बोलो जल्दी बोलो जल्दी बोलो. Okay. Now can anyone give me the idea how to solve this numerical? A rectangular loop area दिया है.
BA cos theta, sir.
Very good boy. What is the answer?
BA cos theta.
BA cos theta. Very good. Fantastic boy. So देखो बेटा, एरिया दिया है. फर्स्ट थिंग इज एरिया इज गिवन. उसके बाद मैग्नेटिक फील्ड भी दिया है बच्चों. फ्लक्स पूछ रहा है. फ्लक्स पूछ रहा है. So we know, लिखिए, we know magnetic flux phi b will be equal to BA cos theta. Very good boy. Very good boy. Phi b is equal to BA cos theta. Magnetic field is given. Area is also given. Cos theta is also given. So we are going to find out the flux. Magnetic flux will be equal to. First you write down the magnetic field BA. B 0.3 टेस्ला हो गया. एरिया सेंटीमीटर में दिया है भाई. तो सेंटीमीटर को मीटर कन्वर्ट करने के लिए क्या करना है? मैंने क्या सिखाया था?
10 raised to power minus 2.
10 power minus 2. Very good. Congratulations. So 20 into 30 is equal to कितना हुआ भाई? 2 3 6 600 सेंटीमीटर स्क्वायर हुआ भाई. सेंटीमीटर स्क्वायर हुआ. तो उसके बाद क्या होएगा? 600 इंटू सेंटीमीटर स्क्वायर हुआ तो 10 पावर माइनस 4 हुआ. और इसके बाद क्या होता है? 10 पावर प्लस 2 10 पावर माइनस 2 को कैंसिल करें तो 6 इंटू 10 पावर माइनस 2 हो गया. सही है? बोलना रे शलसबील, बोलना रे, सही है या नहीं है? बढ़िया. बताओ. 10 पावर प्लस 2 10 पावर माइनस 4. तो प्लस 2 माइनस 4 कैंसिल करें 10 पावर माइनस 2 हो गया. तो एरिया भी मिल गया मेरे. तो बी 0.3. एरिया मेरे को मिला 6 इंटू 10 पावर माइनस 2 मिला. cos theta. Who will say what is cos theta?
90.
60. 60.
Huh?
30. Sir, 30 दिया है ना?
What is
Cos
the
theta
angle?
30.
60.
What is the angle? Tell me what is the angle? Which angle we have to take?
The area vector with respect to area vector.
With respect to area vector, what is the angle made? What is the angle made?
60
90
degrees.
minus 30.
60 degree.
90
Who said the
minus
answer 60? No, who said 60 degree?
Man,
Who said
Aisha.
60 degree? Congratulations to them. नाम बोलिए. Aisha या Faliha? Who said?
दोनों में sir.
Okay, who it may be? Listen very carefully. Magnetic field. Imagine that magnetic field line is going like this. Magnetic field lines are going like this. Okay. So this is the magnetic field lines. This is the magnetic field lines. D vector. Magnetic field lines. Now I am going to keep that plate with an inclination of 30 degree. So this is, imagine that this is the plate. This is the area vector. This is the area vector. I'm going to keep like this 30 degree. So 30 degree magnetic field lines के साथ 30 degree कर रहा है. So imagine that this is the area with making us 30 degree. So now इसका एरिया वेक्टर क्या होता है? ये होता है. ये होता है एरिया वेक्टर हो गया. यानी क्या? This is the area vector. Now if magnetic field lines के साथ ये 30 degree make किया तो suppose what is this angle? So this angle, because magnetic field lines and area vector I want. This angle only I want. I don't want this 30 degree. So 90 minus 30. How much?
60.
How much 90 minus 30? 60. Very good. So cos 60 you have to put. Because this theta has helped you where you are take from the magnetic field lines to the area vector. Magnetic field to area vector. ये लेना है. अगर ये ले लिया आपका आंसर गलती हो जाएगा. So some students they put cos 30 degree, so they will get wrong answer. So please remember always, that's what I'm telling you. This theta represents between these two magnetic field lines और area vector यहाँ बना. इस area तो ये normal, ये area vector यहाँ पे बना है. So this 30 if you take, that is wrong answer. So cos 60 degree. What is the cos 60 degree answer? Answer क्या है? Cos 60 का
1 by 2.
0.3 into 60 to the power minus 2. अरे एनी वो मैथ्स स्टूडेंट बोलिए ना भाई, व्हाट इज cos 60?
1/2.
by 2.
अरे ये बच्चों cos 60 क्या है बच्चों, देखे
1
तो
by
बोलो।
2.
1/2 sir, 1/2.
ओके 1/2, तो इसको सॉल्व करे तो यू विल गेट द आंसर. आई गिव यू द बुक आंसर. इट इज afterwards you check 0.9 into 10 power minus 2 Weber. 0.9 into 10 power minus 2 Weber is given. So this a kind of board question. इसको 2 mark 3 mark में पूछ सकते हैं बच्चों. Now next question, shall I rub the board? So here, what do you understand very clearly? How I am keeping the area vector, in which angle it makes. So 30-degree inclination that you should not take. 45-degree inclination that you should not take. The 20-degree inclination that you should not take. So what you should take? Where is the area vector? First you draw the area vector. Area vector or magnetic field इनका साथ क्या angle होता है? That only you have to take. So that concept we learn from this numerical. because cos theta depends upon B and A. याद रख लीजिए. हो गया बच्चों? हो गया, हो गया, हो गया, जल्दी बोलिए.
जी हो गया सर.
Done.
Next question, please do it yourself and give me the answer. Okay. The magnetic flux 11th standard concept used to the magnetic flux is given by the magnetic flux is given by phi equal to 5t square, sorry 5t cube plus 4t square plus 2t minus 5 plus 2t minus 5 Weber. Calculate induced current at time t equal to 2 seconds. Time t equal to 2 seconds. If resistance is 5 ohms. Yes, बच्चों. This type of question you may expect in your board exam 3 mark. कैसा कर सकते हो बोलिए. Use the 11th standard का concept use करो. Differentiation, integration ऐसा कुछ भी you do yourself and find out the induced current. I'll give you 2 minutes time. 2-3 minutes you can take. But please use properly differentiation and all.
For 15.6,
15.6. Who said the answer?
Aisha.
Aisha, very good. Look देख के बोले क्या? Are you solved?
Solve की sir मैंने.
Solve
Sir
किए,
मैंने
very
solve
good.
की हूँ.
Very good Aisha, very good Aisha. Mashallah, mashallah. Mabruk Aisha. Good. So can you help me बेटा? ऐसा करना है तो थोड़ा हेल्प करो ना.
पहले डिफरेंशिएशन करना है और फिर बाद में टी की वैल्यू पुट करना है और फिर ई बाय आर करना है.
So calculate the induced current पूछ रहा है. तो induced current means current का सिंबल होता है I होता है. तो current का फार्मूला होता है उसका I equal to V by R होता है. Because you know the Ohm's law V equal to IR. तो V equal to IR में देखो I equal to V by R बना. तो V का EMF भी लिख सकते हैं बोला था मैंने. So EMF by I equal to E by R is the formula. So this is the formula बच्चों. तो मेरे को चाहिए induced EMF चाहिए और resistance चाहिए. resistance तो क्या है बच्चों? EMF चाहिए. So first we have to find out the EMF. So EMF का फार्मूला होता है d phi by dt. d phi by dt. So differentiation of phi with respect to time. Class. Differentiation of phi तो दिया है भाई यहाँ से equation. So d by dt of phi का जगह substitute कर लीजिए. 5t cube plus 4t square plus 2t minus 5. Class बच्चों 11th standard का concept अप्लाई करो. Differentiate this equation with respect to time. differentiate this equation with respect to time. So I get the answer is 5t cube. तो 5t क्यूब, तो यहाँ पे डालो 3t स्क्वायर बन गया, तो nx पावर n माइनस 1 है ना बेटा, सो 3t स्क्वायर बन गया। उसके बाद इसका डालो 4 इंटू 2t बन गया, इसका डालो 2 बना, t तो 1 हो गया, 5 0 हो गया ना। तो व्हाट्स आंसर एट t, क्या टाइम, कितना टाइम दिया है भाई, 2 सेकंड्स दिया है, एट t इक्वल टू 2 सेकंड्स। तो व्हाट्स आंसर 5 3 आर 15, t का जगह डाल लो 2 डाल लो, सो 2 स्क्वायर प्लस 4 2 आर 8, 4 2 आर 8, 8 इंटू t का जगह डाल लीजिए 2 सेकंड प्लस 2, सो द नेट आंसर इज 4
78.
60 हुआ, और ये क्या हुआ 8 16 हुआ, और ये क्या हुआ 2 हुआ, तो बच्चों क्या हुआ 60 76 78 हुआ मेरे को EMF 78 वोल्ट मिला। ओके बच्चों, तो नाउ सब्स्टिट्यूट द करंट का इक्वेशन में सब्स्टिट्यूट करो, I इज इक्वल्स टू EMF इज 78 मिला, और रेजिस्टेंस क्या दिया है भाई 5 दिया है, तो 15 पॉइंट क्या बोले 15 पॉइंट, हेलो
6.
15.6 amps is the answer. Fantastic. I equal to 15.6. Please copy. After finishing, please tell me all of you so that I can give you the next numerical, wonderful numerical. The next class we are going to see again the derivation. Tomorrow we are going to see derivation. Finishing, please tell me yes,
Sir,
yes.
tomorrow class will be at
Which time you want? You tell me. Your convenient time. You tell me. I'm convenient with the whole day, so you can tell me the time. You can fix the timing.
sir, I think we could do 4:30, like 7
You want
time.
afternoon timing?
Yeah, sir, 7 Indian time.
That is evening, night you want 7 to 8:30 night.
Yes, yes.
Anybody? All of you agreed?
Like the
Hello?
last two classes we did.
Like last class 7 to 8:30 p.m. you want?
Yes, sir.
Okay. Anybody? Anybody is not agreeing? Please tell me, बच्चों. How many is there? 50 ना? I'll ask Suraya. 7 to 8:30 is okay? जल्दी बोलिए.
जी.
Ayaz 7 to 8:30 okay? अरे monkey Ayaz बोलना रे monkey Ayaz. Are you there or not? Ayaz 7 to 8:30
जी
is it
सर
okay?
जी
Okay. Ayman 7 to 8:30.
Yes, sir.
Darwin 7 to 8:30 p.m.
यस सर
Okay, so Faliha, Fatima, Man Patel, Muhammad Ali, Musfira, Nishtha, Rayan, Rihab, Shariar, Sheikh Muhammad, Suraya. So 7 to 8:30 p.m. tomorrow class. Please don't forget, बच्चों. Now next question, last question, बच्चों. और एक क्वेश्चन देखिए अभी. What is the time? Can you tell me the timing? What is not here? बच्चों टाइम बोलिए थोड़ा.
Sir, 8 minutes are left.
कितना बेटा टाइम है अभी बाकी?
8.
Okay, then we can do one more numerical. Simple numerical only I'll give you. Very good children. Now you understand the differentiation पूरा कैसा करना है, और काइल कौन सा inclination में रखे तो 30 डिग्री 40 डिग्री 20 डिग्री, अरे भाई कुछ भी inclination दे दो. So we will find out nothing. We won't worry that we will find out that phi equal to b a cos theta. तो cos theta कहाँ से कौन से बीच में होता है? मैग्नेटिक फील्ड का डायरेक्शन का और एरिया वेक्टर. तो ये हो गया एरिया, तो एरिया वेक्टर कौन सा होता है? ये होता है. तो एरिया वेक्टर और मैग्नेटिक फील्ड का डायरेक्शन का बीच में ही हमें लेंगे, तो वो जो देता है 30 डिग्री 20 डिग्री वो नहीं लेंगे. तो इतना याद रखना बच्चों प्लीज. उसके बाद हो गया सो वन मोर वंडरफुल कॉन्सेप्ट. तो ये थोड़ा लेंथी क्वेश्चन होता है, अभी इसमें नहीं हो पाएगा बच्चों क्योंकि ये थोड़ा लेंथी क्वेश्चन हो रहा है. तो दैट ग्राफिकल क्वेश्चन इंशाल्लाह आई गिव यू नेक्स्ट टाइम. ओके, तो उसके बाद नेक्स्ट टाइम दे रहा हूँ मैंने. थोड़ा दो क्वेश्चन भी बहुत बड़े बड़े क्वेश्चन है बच्चों. आई गिव यू नेक्स्ट टाइम, डोंट वरी.
कोई बात नहीं सर, कल करेंगे.
कल करेंगे. So you are very happy to close the class. Okay.
जी.
Okay. One more class. Just 1 minute. 1 minute. I will close the class. Let's go, beta.
Okay,
So,
sir.
you know what I taught you? Phi equal to EMI का चैप्टर में क्या देख रहे हैं बच्चों, इलेक्ट्रोमैग्नेटिक इंडक्शन का चैप्टर में क्या कर रहे हैं, find the flux. So magnetic flux. So phi E. This is what we studied, electric flux. Electric flux we studied in the first chapter. So what is electric flux? Electric flux is nothing but EDS cos theta. EDS cos theta. Circuit integral of EDS cos theta. Or you can write the same formula like this: E vector dot A vector. So vector formula लिखा तो E vector dot A vector, you write EDS cos theta. So this is what we studied in the first chapter thoroughly. Same thing we are going to study here. Phi B equal to EDS cos theta जगह डाल दो BA cos theta. So BA cos theta. So again and again I am telling you this theta कहाँ से कहाँ तक लेना है, मैग्नेटिक फील्ड का डायरेक्शन और एरिया वेक्टर का डायरेक्शन बीच में ही देखना है. तो दूसरा कुछ कंफ्यूज नहीं होना है. टू डू द न्यूमेरिकल जस्ट नाउ आई स्टार्ट यू वेरी क्लियरली. So this you can write as B vector dot A vector. So दोनों का similarity आप देखिए, you will get the same thing only. Phi B equal to BA cos theta, phi B equal to EDS cos theta. First thing you understand. Now there are three parts in this EMI chapter. May we are going to study three parts. The questions introduction you should know. What all things we are going to study means when flux is EMF is produced or flux is produced, when the flux is produced, the phi B is produced. So as I told you, when the magnetic field is changing, flux is produced. Second thing we are going to see, when the area is changing, area is increasing or decreasing. Area is increasing or decreasing, flux is produced. Magnetic field is increasing or decreasing, flux is produced. Then we are going to see cos theta is increasing, cos theta is decreasing, flux is produced. तो ये तीनों चीज याद रखो बच्चों, ये तीनों में कुछ एक तो चेंज हुआ तो फ्लक्स इज प्रोड्यूस. ओके, दिस थिंग you have to understand. So now next class what we are going to see means when the area is, so what is the thing they have given here means when magnetic field lines are changing, flux is produced. Okay, when area is changing, area the increase किया हो या decrease हो, again flux is produced. तो इसका नाम होता है motional EMF. The topic is comes under the motional EMF. How the movement of the conductor, when the movement of the conductor is increasing or decreasing means ये area पे एक conductor move हो रहा है, तो move हुआ तो area decrease हो रहा है या increase हो रहा है. So how the flux is produced, this is what we are going to see tomorrow class. That is area increase किया हो, area decrease हो, we are getting the flux is produced. So इसका topic होता है motional EMF. How the EMF is produced. EMF is produced. EMF का फार्मूला क्या होता है? EMF का फार्मूला क्या होता है? EMF का फार्मूला होता है d phi by dt. EMF का फार्मूला होता है d phi by dt. तो d by dt या फ्लक्स क्या होता है? फ्लक्स इज नथिंग बट VA का. फ्लक्स इज नथिंग बट VA का. तो अगेन देखो आपने, एक तो मैग्नेटिक फील्ड चेंज होना है, राइट, एरिया वेक्टर चेंज होना है. तो इन दूसरा भी नेक्स्ट क्लास टुमारो वी आर गोइंग टू सी व्हेन द एरिया इज इंक्रीजिंग और डिक्रीजिंग EMF is produced. So that name is called motional EMF. See you bye inshallah. Take care. Allah Hafiz. Bye bye. Okay, tomorrow we'll see. Okay.
Yes, sir.
Okay.
Thank you,
Take care.
sir.
Allah Hafiz. Bye bye.